Okay, so continuing with the history of the atom, this is question 2. We're going to start looking at Rutherford's experiments, another key scientist you need to be aware of. And what he did was he passed alpha particles straight toward a piece of gold foil. And what he noticed was that most of the alpha particles went straight through. And obviously at the time, this was a bit of a surprise. And only a few of the particles actually bounced back at 180 degrees and came straight back to the emitter. So the question is always asking is, why does most of the alpha particles pass through the foil? And the reason being is, if we think about what was the original kind of description of an atom, in that they thought they were solid spheres arranged in a regular arrangement, then obviously that wouldn't have explained the experimentation results that you saw. However, what these results did suggest was that at the center of each of their atoms, there was a very dense area or region of space. And as he fired the alpha particles at the substances, most of them just went straight through most of the empty space. And it was only every now and again when something actually hit the nucleus in the middle did it then start to bounce back. And the reason being was that actually, contrary to what they'd thought of at the time, was even though we draw them as circles, most of the circle is actually empty space. So most of this is empty. We now know that the central nucleus contains the protons and the neutrons and the vast majority of the mass of an atom. However, in terms of physical containing of a substance, most of the atom is actually empty space. So the helium atoms, the helium nuclei, the alpha particles, fired straight through the gold leaf, didn't hit anything, went straight through the other side. But as I say, in terms of the green one, every now and again, one came straight back because it hit that very dense nucleus. So why then, to answer the question, why did most of them pass through the foil? Most of an atom is empty space. Okay, so there was actually nothing. Most of an atom is empty space. So there was nothing for that alpha particle to actually hit. And when Rutherford continued on with that nuclear model, he then suggested that the electrons were existing in specific orbits and orbiting the nucleus at specific distances. This specific distances idea was obviously taken from Rutherford's idea, developed slightly further, and this was introduced by a man called Niels Bohr. Again, another scientist we need to be aware of, and it's one of his ideas now, which allows us the kind of 288 situation that we use today.